Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 2 for the chapter Units and Measurement. So let's begin today. Dear all, today we are going to discuss about the dimensions. Now let's look at this. What are the dimensions and how they behave? Now what we are going to do is we are going to first know about the dimensions, then we proceed further for their applications and how questions has been asked from the topic dimensions. So let's look at this. First, what are the symbol for the dimensions of fundamental units? We know the SI system. We know there are 7 fundamental quantities in the SI system. One is the length, another is the mass, third is the time, fourth is the temperature, fifth is the current, sixth luminous intensity, and seventh amount of substance. What we have done is we have given a certain keyword to every quantity. Let us suppose say for the length it is capital L, for mass it is capital M, for time it is T, for temperature it is Kelvin. So we have represented K. A certain time you will observe that there are certain books which are using a theta, so you can use both. You can use either K or theta, but K would be a more preferred. Okay. For current, generally I, or sometimes it would be an A. Luminous intensity it is CD, and amount of substance it is a mole. So please do remember, I will repeat one more time. For length it should be an L, for mass it should be an M, for time it should be a T, for temperature it would be an K, current I, luminous intensity CD, amount of substance mole. How this will used? So let's say we are going to produce a dimensional formula certain. So what we can say dimensional formula is, it is the expression of one unit of derived physical quantity. Now what does it mean? So let us say we have a certain physical quantities P. For P we are going to represent this into a certain terms, that is m to the power x, l to the power y, t to the power z. Now this x, y and z, this x, y and z are the dimensions of that physical quantity. And when we write this in a bracket, this complete bracket represents dimensional formula of this quantity. So one more time, whatever the powers of the m, l, t and onwards, a, k, theta and something like that, whatever the powers are there, they are the dimensions. And when we write this complete in a bracket, generally we are using a square bracket, it is a dimensional formula. So let us try one by one. We need to find out the dimensions of the speed. What are it? So first, to find out the dimension, first step would be, you must know what would be the relation or what would be the equation of a speed. So we know that the speed is equals to distance by time. Now I need to consider in which segment distance should be considered. I know distance is considered in length, time it is there only. So here if you can observe, distance having a power 1, time is having a power 1. So when I write distance, I should write m to the power 0 because it is not having a mass, length to the power 1 because it isn't having a value power of 1, and time is not there, so t to the power 0. In time, look at this, m to the power 0, l to the power 0, t to the power 1. So when we are going to solve this, what we are observe is, this is m to the power 0, m to the power 0, so my answer would be having an m to the power 0. This is l to the power 1, l to the power 0. You might know that when base are same and you need to perform a division, there would be a subtraction of a powers. And when base are same and you need to do a multiplication, you need to do an addition, such as x to the power 5 divided by x to the power 3. So if it is something like that, this is x, this is x, so this should represent as x to the power 5 minus 3, because it is a division, so this comes to an x square. But if it is something like that, x to the power 5 multiplied by x to the power 3, then this should represent as x to the power 5 plus 3, and this comes to an x to the power 8. I hope it seems clear. So now we know this is m to the power 0, l to the power 1 minus 0, t to the power 0 minus 1. So this is m0 l1 t minus 1. This is m0 l1 t minus 1. It is a dimensional formula of physical quantity speed. Clear? Okay, let's move on. One more. We need to find out the dimensional formula of temperature gradient. So first thing, what is temperature gradient? You might know what temperature gradient is. Temperature divided by distance. Remember one thing, when and when word gradient would be there, when and when, every time you need to divide certain quantity with distance. Let's say it is an voltage gradient. Voltage, do you know what is it? Then yes, you have used in class 10, V is equals to IR, voltage potential difference, whatever you are calling it. So this is voltage divided by distance. So do remember one thing, when and when gradient would be there, it is a certain physical quantity that would be divided by distance. So again, back to the point. So temperature gradient, it is a temperature divided by distance. So temperature, how it could be a represents, it is a it would be come into the category of an temperature, it would be measured by an Kelvin. So this is m0 l0 t0 and k1. Distance, you know, that is in length, so it would be an m0 l1 t0 k0. So here it is a 0, this is m0 l0 minus 1, this is 0 minus 1 to the power l, t to the power 0, k to the power 1 minus 0, and m would be a 0 only. So this comes to an m0 l minus 1 t0 and k1. Clear? Let's move on. Next, find out, determine the dimensions of force. Now you need to do it by yourself. Tell me the steps, what we can write. First formula would be required. What is the formula of a force? You know, think for a while. We know this force is equals to m into a, while m is the mass and a is the acceleration. Now what are the dimensions of mass? What are the dimensions of mass? We know that it is a mass to the power 1, so this is m to the power 1. It is not having a length, so this is l to the power 0. It is not having a time, so this is t to the power 0. Clear? So this is for mass, m1 l0 t0. Next is the acceleration. What is acceleration? Think. This is change in velocity. Divide by time. So how change in velocity will represent? It is a meter per second. One more second would be there because of time, so this comes to a meter per second square. It's a meter divided by second square. So this quantity does not having a mass. This means it is m0 l1 t to the power minus 2. Now we are having in dimensions of mass, we are having in dimensions of acceleration. Now I need a force, so that should be is equals to m into a. For mass, I need to write m1 l0 t0 multiplied by m0 l1 t to the power minus 2. So this becomes m to the power, here it is 1, here it is 0, so this 1 plus 0, that becomes 1. Here it is 0, here it is 1, this is 0 plus 1, 1. Here it is 0, it is minus 2. So this is m1 l1 t minus 2. This is force, and this represents dimensions of force. Dimensions are the 1, 1 minus 2, and if we ask for the dimensional formula, it would be an m1 l1 t minus 2. Please do one thing. When I am writing here, you just write it over your place itself. This will make more things clear. It would be a more clear. So please do it. Let's move to the next. One more attempt. Determine the dimensions of work done. Do you know the formula of work done? Do you know it? Try to remember. Did you use it before? Work done in class 9? It's in work power energy. So work done, what is work done? It is a force multiplied by displacement. So my requirement would be, first I need to find out dimensions of force. How could I get it? So I know this force is equals to mass into acceleration. What is mass? It's kg. Acceleration we have used previously, so I know this is meter per second square. So for the force, kg power 1, this is m to the power 1. Meter comes in a length, power 1, it's an L to the power 1. Second comes in the time, it's a T to the power minus 2. Clear? Next, displacement. What is it? It is the shortest distance between 2 points, or rather we can say shortest distance between origin and destination. So it's in length basically. So we should write it m0 l1 t0. Now work done, or sometimes it has been called as in work. So this is force multiplied by displacement. Here I have written F as a force and X for the displacement. What is F? It is m1 l1 t minus 2 multiplied by displacement. This is m0 l1 t0. Now when base are same and you need to perform a multiplication, it would be an addition of the powers. So this is m to the power 1 plus 0, which is 1, L to the power here 1, here 1, so this comes to a 2, t to the power minus 2. So this is m1 L2 t minus 2. Can you do it? Yes. Move on. Next, determine the dimensions of charge. What is it? And how could I find it? Do you know any relation which can relate a charge? Do you know this? I is equals to Q by T, where I is the electric current. Q is the charge. And T is the time. So from this, I can write it. Q is equals to I into T. Now, what can I write for the I? Try to remember whether I, it was an electric current, was there in an SI quantities, in a 7 fundamental quantities of SI system? Yes, it would be. What was its unit? Its unit were ampere. So what I can write here is, this is ampere. For time I can write second. So this is ampere to the power 1, second to the power 1. So sometimes you will find that certain authors have written as a to the power 1, t to the power 1. But it would be better to use this notations m0, l0, t1, a1. Both things are same only. Here we have written m0 and l0 as an additional. No mass would be there, no length would be there. So I have written there as in power 0. They are the m0, l0. And time is there, time is having a power of 1. So I have written as a t to the power 1. And a represents the electric current, stands for the its unit ampere. So it is a to the power 1. So this is m0, l0, t1, a1. Yes, remember the dimensional formula of a charge, very helpful. Next, Determine the dimensions of voltage. Do you know any relation? Do you know any relation that can get us the dimensional formula of the voltage? Here you might know that, sir, I know one relation which is V is equals to IR. Let's say this, V is equals to IR. But think while, do you know the dimensions of voltage? No, sir. Do you know the dimensions of I? Yes, sir. Do you know the dimensions of R? Again, no, sir. I don't know the dimension of this. That's why I'm doing this. I don't know the dimensions of this also. That's why. Then how can I, if it is a single relation only and there are two unknowns? So what I mean is, you cannot use this relation to determine the dimensions of the voltage. So V is equals to IR. Relation is correct, absolutely correct. But you cannot get the dimensions of voltage with the help of V is equals to IR. So I need to go for some other relations. Think what I can do. Any other relations that you know? Any other relations for the voltage? Do you know anything? We have one more relation. This is work done divided by charge. It's an voltage. This is voltage. This is work done. And this is charge. So, do you know the dimensions of work done? Yes, sir. Do you know the dimensions of charge? Yes, sir. So, go for it. How could I write it work done? Work done is force into displacement. Now you know. What is force? It's an mass into acceleration. What is x? It's an displacement. This is meter. Do not get it confused. This m stands for mass. So when I write a unit of this, this is kg into meter per second square, divide by second square, multiplied by meter. So this is kg multiplied by meter square divided by second square. This is for the work done. Next, charge. Q is equals to IT. We have done this in previous slide only. So this is equals to ampere into second. Now turn for an voltage, which is work done by charge. So work done, I can write it like this: kg meter square per second square multiplied by q. This is 1 by ampere into second. I hope these things are clear. This is q. Now here second square would be there, here second would be there. So what I can write is kg into meter square divide by, this is second square, this is second. So this is second to the power 3. It's in second cube multiplied by ampere. So that should be kg to the power 1. So this is mass to the power 1. Meter to the power 2. This is L2. Second to the power 3. But it is in an inverse ratio. So I should write T to the power minus 3. Ampere to the power 1. But again in an inverse. So this is M1 L2 T minus 3 A to the power minus 1. Clear? Yes, there are certain chances that you might not having an practice with the work done. So what you need to write is, go with the basic systems, go with the basic formulas, just like a length, just like an area, just like an volume. Then go for the force, then go for the speed, go for the velocity, go with the acceleration, and something like that. But you need to practice hard to develop a dimensional formula of a quantity. You just cannot remember all the quantities, and you just cannot remember the dimensional formula of all the quantities. You need to practice this only. That is the only solution what you can do. You cannot remember it. So I am here to practice you certain quantities. Other certain quantities will be done by you only. So keep it up and keep going. Let's move on. Next, determine the dimensions of voltage, that we already done. Determine the dimensions of voltage, that that we have already done. So this task is done. This slide is kept purposefully blank so that you can write it down. So do remember, you need to find out the dimensions of the voltage, but you cannot copy it from the previous slide. So what are your basic steps? I can give you the hint. Can we use V is equals to IR? Yes, absolutely not. So V is equals to IR is not available for dimensions. So what we should write? Remember, you have seen it just this time. So we know this is voltage should be is equals to work done by charge. Now what would be the relation of work done? Work done would be force into displacement. What is the relation of the charge? It is I into T. Now what would be the next step? You know that F is equals to mass into acceleration. Very good. Now write it down, the units of this. You yourself will do it. Take your time, but do it. Now write it down, the units of displacement. Take your time and do it. Have you done it? Great. Next, write it down, the dimensions of I into T, which is a charge. Done? Look at your book. What you have written? It's an ampere into second. If you did it, great. If not, look at here. Next, V should be is equals to work done by charge. Write down the dimensional formula of work done that you have derived here. Write down the dimensional formula of ampere into second, and then just solve this. So can you do it? Very good, great work. Let's move on. Determine the dimensions of resistance. Determine the dimensions of resistance. Now any formula regarding the dimensions of resistance, how you can do it? Any relation that comes in your mind through which we can move further or we can move forward for the resistance? Is there anything? Yes, here you can use Ohm's law. V is equals to IR. Why? Because now we know what is voltage, we know what is current. So if only one unknown would be there, we can solve it. So first, R should be is equals to V by I. What is V? We know V is equals to work done divided by charge. We know work done is equals to voltage is equals to work done by charge. What is I? What is I? We know that I is equals to Q by T. So if I write, this is Q by T. So this is work done into time divided by Q square. Now what is work done? Remember this cycle. This will help you. What is work done? This is force into displacement multiplied by time divided by Q square. Q is equals to IT, that you know. So this is ampere square multiplied by second square. This is T square. Here T are having a power 1. Here T square would be there. So we can solve it. Force, what is it? This is kg meter per second square multiplied by x. This is meter multiplied by, here it is T square, on an upper side it would be an T only. So this will make this T only. So, and one more thing, this is an ampere square. So what I have written is, this is for force, this is kg into meter per second square. This x represents this meter. Here it is T, here it is T square. So if I cut it down, it would be an 1 by T. And one more thing, it is an ampere square. So if I solve this, it is kg meter square divided by ampere square. Here it is second square, here it is time, so even time represents the second. Yes, absolutely. So this is kg into meter square upon ampere square multiplied by second cube. Now write down the dimensional formula of this. What would be the dimensional formula? This is m to the power 1 meter square, it is L to the power 2 ampere square, but on an inverse side, second cube T to the power minus 3 A to the power minus 2. Yes, is it clear? Let's move on. Dimensional formula of capacitor. Do you know what is this? Capacitor. Have you heard about this? Capacitor? No? Have you heard about the capacitor? No? Okay. Basically, this is a component which stores the charge. You will learn about the capacitor in class 12. It is a second unit. Uh, we say this is the electrostatics under the segment of electrostatics. You will learn it in class 12. But you must know the dimensions of capacitor. How? First, let us learn the relation for the capacitor. It is a Q is equals to CV. Q, it is a charge. C, it is a capacitor. V, it is a voltage. So C, that would be Q divided by V. Do you know the charge? Yes, very good. Q is equals to I into T. Do you know the voltage? Yes, this is a work done by charge again. So this is charge, this is charge, this is Q square divided by work done. Now you can write it down on your own. For Q, you will write ampere into second. For work done, you will write it is as an force into displacement. For force, you are going to write mass into acceleration. For displacement, it is an meter. For mass, you are going to write kg. For acceleration, you are going to write meter per second square. Here purposefully I have not written anything because I want you yourself write it. So I am keeping this for you guys so that you would have a practice. So do it. Purposefully I have left it blank. So this is capacitor. Do remember. Yes. Do you want to know about one more component? Is it? So do remember this thing. A one component is there which we call as an inductor, and its symbol is L. At this point of time, you just remember its formula. We say V is equals to L multiplied by I divided by T. Hold on, I'm telling you the meaning of every symbol. This is V. V stands for voltage. L stands for inductor. I stands for current. And T stands for time. These are all symbols. Now do one thing. You need to find out dimensional formula of inductor. It's your task. Try to do it. If not, let me know. I will help you. But do an attempt. So I hope with this many practical questions you are able to create a dimensional formula of quantity. So next, move to the physical quantities. On the basis of dimensions, we are going to divide every physical quantities on the basis of dimensions in 4 categories. The first category would be they are the dimensional variable. Now what is it? Dimensional variable means they are having a dimensions but they does not have a fixed value. I hope you understand the meaning of variable. Variable are the values which are not fixed. That's why they are called a variable. If they are the fixed, they would be said as a constant. So these are the dimensional variables. Everything, every quantity, let's say pressure, let's say force, let's say velocity, let's say work done, this all are the dimensional variable. So they are having a dimensions, that means they are having a dimensional formula, and they does not possess any fixed value. Let us suppose we said F is equals to 5 Newton. F it could be 8 Newton, F could be a 10 Newton, F could be a 20 Newton. So these are the variables. It could have a various values. Same thing is true for the velocity, acceleration and onwards. The second category, second quantity we say is dimensionless. Look at this. This is dimensionless variables, which means they are not having any dimensions, and but they are variable, so they does not have a fixed value. Which are they? Do you remember plane angle and solid angle? Do you remember it? What are they? Please try to remember. There are three categories of physical quantities. One is the fundamental quantities, which are the seven systems, or which are the seven quantities of SI system. Another are the derived quantities, those quantities which can be derived with the help of fundamental quantities. They are the derived quantities. And last, they are the supplementary quantities. Two quantities would be there. First two, one would be the plane angle, another would be the solid angle. So plane angle and solid angle are the dimensionless variables. These are the quantities. These are the quantities which are having units but not the dimensions. But let us suppose refractive index. Do you know this? Have you used it? In which class? 10th class. Yes. So you know that n is equals to c by v. So basically it's a ratio of similar quantities. What is c? It's in speed of light in air, or we can say vacuum. V, it's in speed of light in medium. So it's a ratio, it's in speed basically, na? It is a ratio of speed only. So for speed, you can write this is meter per second. For this speed, even you can write meter per second. So if we are going to ask the dimension formula of this refractive index, we just say it is an m0, l0, t0, because they are having no dimension. 0, 0, 0. Yes, plane angle and solid angle having the same theory. Try to remember what is the formula of theta, what we call as in plane angle. It's an arc by radius. Arc is measured in length, it's in meter. Radius is measured in length, again it's in meter. So meter to the meter, it would be a cancelled out. So plane angle are having units but not the dimensions. So do remember one thing, plane angle and solid angle, plane angle and solid angle are having units but they are not having a dimensions. Yes, please keep this in mind. Next, move to the next quantities. The third category is the dimensional constant. Now look at the word constant. That means they are having a fixed value, a value which cannot be changed, but they are having a dimensions. Yes, so they are having a dimensions, they are having a fixed value. Like, do you remember a gravitational force? This is F is equals to G m1 m2 divided by r square. Learned it in class 9, unit number gravitation. So here G would be is equals to F into r square divided by m1 into m2. Value of a G would be 6.67 into 10 to the power minus 11. Its unit would be, look at this, force measured in Newton. R is the distance, so r square, this is meter square, divide by m1 m2, this is kg square. So this is 6.67 into 10 to the power minus 11 Newton into meter square divided by kg square. This is its units, and you can find out the dimension of this with the help of Newton into meter square divided by kg square. This value is fixed, that's why it is called as a constant. So this is dimensional constant. Same way gauge constant would be there. Planck's constant would be there. There are many others. When you go through the several units of a physics, you will find more. But these are some examples. Try to remember. And last category, that would be a dimensionless constant. That means they are having a fixed value. That's why it is called as a constant. But they are the dimensionless. They are not having any dimensions. They are not having any dimension. So they are the dimensionless constant. So what are they? They are not having any dimensions, but they are having a fixed value. That means something like numbers, a 1, 2, 3, and much more. These are the 4 different categories in which we can divide our physical quantities according to the dimensional formula. So, do you want a revision? Yes. First is the dimensional variable, which are the variables. That means the value would be changes, but they are having a dimensions. Another, it is a dimensionless variables. They are again variable. That means they are having a variable value. They are having a changing value, but they does not possess any dimensions. M0, L0, T0. Third category, it is a dimensional constant. They are having in dimensions, but they would be having a fixed value. They are the dimensional constant. And last but not the least, it is a dimensionless constant. So they does not have dimensions, but they are having a fixed value. Does it clear? Yes. Okay, let's move on. So now come to the basics. Why we are using since the starting of this lecture dimensional, then why do we use it? Why we are doing this? From last 37 minutes we are talking about the dimensional formula. What is the help of it? How they can help us? So we are going to learn this only. Uses of dimensional formula. Basically these are the applications of dimensional analysis method. So let's look at this. First, to check the correctness of the given equations. Here I have just summarized these applications. So next, from the next slide we will learn them one by one. So first, how do it help us? It will help us to check the correctness of the given equation. Next, this is used to convert one system of units into another system of units. Let's say suppose a certain unit would be in SI system, and if I need to convert it into a CGS, then this can help. How? We will look. Next, to derive the equation showing the relation between different physical quantities. This is very interesting. You don't know the basics behind it, but you can derive it. Let's say suppose you know the force is depends on the mass, is depends on the velocity, is depends on the radius. You don't know their power. Let us suppose the A, B and C. You even don't know the name of this force. You don't know the real physics behind it, but you can derive this relation. Again, there are certain limitations, but the main thing is you can derive a relation between F and M, V and R. This is the beauty of a dimensional analysis. Okay, we will learn it. Next, in the case of physical quantities which depend upon more than physical methods, more physical quantities, this method will be difficult to obtain physical equations. We will learn this, that how this could help, how this could not help. So first let us go to the one by one basic applications of dimensional analysis, how this help. So first, let's begin with to convert a physical quantity from one system of units to another system of units. So if I ask what is 1 meter, you say 1 meter is equals to 100 centimeter. Yes, correct. Yes. Now look at this very carefully. What is 1? You will say, sir, it's a number. What is meter? You will say, sir, it's a unit. What's an 100? Again it's a number, and this is its unit. So what you have written is N1 U1 is equals to N2 U2. This is true for every quantity. So for each quantity you can write Q quantity is equals to N into U, or rather you can write N1 U1 is equals to N2 U2. Yes, so this is true. This can be written for each and every quantity. This can be written for each and every quantity. So what I will use, or what I can write is, this is N1 multiplied by its units. How it comes, this depends on the dimensional formula of that physical quantity. Now you know how the dimensional formula of each quantity can be written. Yes, you absolutely know this. Multiplied by N2 multiplied by U2. Let us suppose you need to find out N2. Then solve it mathematically. We are going to show certain examples. Let's look at it. We need to ask convert 1 joule into arc. Now do you know what is joule? It's a unit of energy. And what is arc? What is arc? This is unit of energy itself, but in CGS system. This is the same unit of energy but in a CGS system. So joule, what is the dimension of joule? Yes, m1 L2 T minus 2. So the dimensions are m to the power 1, L to the power 2, T to the power minus 2. This is minus 2. Okay, now what is the CGS unit? CGS unit, this is 1 gram, because in the CGS system these things are measured in the gram. It's in length. Length would be a 1 centimeter. Length would be measured in centimeter, and time would be measured in second. So I need to do this. N1 U1 should be is equals to N2 U2. So N1, what is it? That's in 1 multiplied by U1. It's an unit of joule. What is joule? It's an energy. Energy, how could I write this? This is kg meter square per second square. Yes, so this is kg multiplied by meter square divided by second square. You can write it. Even you can write like this. This is m1 L2 T minus 2. Both are the same thing. And then you can put up the formula a1 b2 c to the power minus 2, as I have mentioned here. Even you can use this system. Whatever suits to you, whatever suits to your style, you can use it. N2 you required. Next U2. It's in second system. Which one? It's an arc. Arc is a unit of CGS. So you know that. Look at this very carefully. This is kg. Kg to the power 1. So here it would be in gram. Gram to the power 1. Multiplied by this is meter square. In CGS system length would be measured in centimeter. So if here this is power 2, here power should be a 2 only. Divide by time. Time is measured in second only. This is second square. Clear? Now what you need to do is you need to convert this any one system, because here it is kg, here it is gram. How you could do it? I would recommend that whatever the bigger units are there, look at this. Here it is kg, here it is gram. So it would be an easier to convert a kg. You know, 1 into 10 to the power 3 gram multiplied by meter square. 1 meter is equals to 100 centimeter. So 1 meter square, it's in 10 to the power 4 centimeter square. Divide by second square. This is equals to N2 multiplied by gram multiplied by centimeter square divided by second square. So solve this. Gram cancelled. Centimeter square, centimeter square. So N2, this is equals to 10 to the power 3, 10 to the power 4. This is 10 to the power 7. This is the answer. So 1 joule is equals to 10 to the power 7 arc. Can you do it? Let's try one more example. You need to convert 1 Newton into dyne. Again same thing. This 1 Newton. Newton is an SI system. Dyne, it's in unit of force only. It's in unit of force only. But in CGS system. Now, from where shall we begin? Yes, correct. N1 U1 should be is equals to N2 U2. You can write 1 Newton is equals to X into dyne. So now Newton, what is it? Remember this, F is equals to ma. M stands for kg. Acceleration stands for meter per second square. Write it, 1 into kg into meter per second square. That should be is equals to x. Now when and when it would be in kg, in the CGS system it would be in gram. There would be in meter in the SI system. Here it would be in centimeter. This is second square. Here it would be a second square. Now what you should do, you need to convert kg to gram, meter to centimeter, and so on. So this is 1 into 10 to the power 3 gram multiplied by 10 to the power 2 centimeter divided by second square. This comes to an x multiplied by gram multiplied by centimeter divided by second square. So this second square would be a gone. Centimeter would be a cancel. Gram would be a cancel. So this comes to x is equals to 10 to the power 3 multiplied by 10 to the power 2. This comes to a 10 to the power 5. So our answer is 1 Newton is equals to 10 to the power 5 dyne. Please do remember this. Yes? Do you want to go for one more? They said if the unit of force is 1 kilonewton, its length is 1 kilometer, and that time is 100 seconds, then what will be the unit of mass? It's a completely a different question. Their unit has been changed, their length has been changed, their time has been changed, and you have been asked what is the unit of mass. How you could write it? Do you know any formula that can relate force, length, and time, and mass as well? So let's write F is equals to mass into acceleration. Yes. So this is mass multiplied by acceleration. What I can write? I can write meter per second square, and this is mass. So kg into meter per second square, this is force. So now think, what I need is the unit of mass. That means this kg is required in a new system. So this kg is equals to F into second square divided by meter. This is length. So now let's try it. How we can do it? So I should write N1 U1. This is equals to N2 U2. I don't know how much kg it would happen. So this is, let us suppose I write x multiplied by its unit. This is kg is equals to n2 multiplied by u2. So this, when we write n2 into u2, so this n2 multiplied by u2, this is force into second square divided by its length. So now this is x multiplied by certain kgs would be equals to n2 multiplied by force. It is 1 kilonewton, so 1 into 10 to the power 3 multiplied by seconds. Here time is measured in 100 seconds, so this is 100 to the power square divided by length. It's in 1 kilometer, so again this is 10 to the power 3 meter. And now you need to solve this for the x. Can you do it? Please try it and do it by your own. But is it clear? You need to convert the unit of mass. So it is a certain numbers with as in kg. Clear? Okay. So here it is. We have learned up till here What are the units? What are its dimensions? How the dimensions can be used? We have learned just one application of it. Now what I want from you guys, you just practice the dimensions very hard. Just practice approximately 40 to 50 physical quantities, make their dimensions, and ensure that you are comfortable with arranging the dimensions of any physical quantity. So if you can do it, it would be a very smooth sections, it would be a very smooth sessions, upcoming sessions for you guys, because now onwards we are going to use the dimensions only in their applications. We have learned one applications and we are going to move in the next session with new applications. Is it okay? Yes. So let's stop this lecture here only. You just do one thing, practice 40 to 50 at least physical quantities for the dimensions. Thank you, have a good day, and bye bye, take care.